My name is Brooke Reeves, and I am doing my Lab 15 on the evolution, on the evidence of evolution. It's going to be based off the fossils part. And so all of the information that I am gathering is from either a website or a textbook. And I'll also list and name those websites as I get later on, and then what is from the textbook. So, for starters, the first question is, what are fossils? By the textbook definition, which I do have a notebook in front of me, as well with all of my notes, just to make sure that I gather everything and properly explain everything. So I would have the definition of a fossil is any evidence of an organism from more than 10,000 years ago. And so the different types of fossils that I'm going to go over, there will be 4 different types. I'm going to go over the trace fossil, body fossil, subfossil, and an index fossil. The index fossil is kind of, I feel like one of the more interesting and important ones, but all of them are pretty cool. So the body fossil first is a fossilized remains of dead plants and animals. This could include fossil bones, teeth, claws, shell, any tree trunks, or any leaves. And then the next one we have would be the trace fossil. That trace fossil is other fossilized signs of a plant and animal. That could include imprints of a skin or any skin, feathers, a nest, any eggs, and then any organic material such as feces. And then it did also list as a bonus coprolites. They can also be used for prehistoric activity. They can be used for like burrows, trackways, or footprints or anything like that. And then the next thing that we have, and the next one we have would be a subfossil. So a subfossil is basically a fossil that is beginning to develop. So it's kind of in the first stages, and the remains are in the first stages of fossilization. Minerals are replacing any biological components. Then this is a direct quote from a professor that was listed on the website that I thought I should include. Professor Paul Barrett said they're usually quite young fossils, often from Ice Age deposits or younger. So from that age or any younger than that, those are considered a subfossil. And then the next fossil we have would be a index fossil, and the index fossil would be used to work out the age of the sedimentary rocks. Kind of an example of that is, I believe it's called ammonites. Those make great index fossils since due to like rapid evolution and wide distribution. Another example of that makes another really good one. Another good index fossil is trilobites. That would be another one that is really good. And all of this info was found kind of according to the Natural History Museum website. So that is the one where I gathered all of that information to find out all the different types of fossils. So definitely feel free to check that as well. And then the next question is kind of, how do we determine the age of a fossil? And so there are a couple different ways that you are able to determine the age and how to date them and when they had begun. One way of dating fossils kind of relies on where they are in the ground and the relative area that they're in. So the bottom layers in a geographical like sequence kind of goes oldest. Like it usually goes the oldest, and then the top layers are the youngest. So the like deeper you go, the older it is, the closer from what I'm gathering to the top means that they're younger, so more recent fossils. When fossils are stacked on top of each other, it's easier to kind of arrange them in chronological order, so it makes it so that we are able to accurately date them a lot easier. They also can measure the amount of radioactive elements around, so often kind of radiocarbon or potassium that they measure. that kind of helps determine when the rock was formed and when the plant or animal died. Scientists are also able to use particle accelerators to measure the amount of carbon-14 in biological materials to kind of determine when the organism had died. This one is kind of more for volcanic, like if it's in an area that kind of has more volcanic matter. I do believe that there was quite a few more areas back then, kind of based off my research. So another method is kind of like as it's, this is stated from, according to the American Museum of Natural History. Ash layers, once they start cooling, potassium-40, the radioactive potassium-40 contained within kind of like breaks down into like rare argon. I believe I'm saying that right. Through that, they can kind of compare the amounts of potassium and argon. Paleontologists can then estimate how much time has passed since the volcanic tuff was formed, and that can also give them another general idea of where that fossil ends up in the timeline and how old it possibly could be. And then the last and final question was, how do fossils contribute and help support the theory of evolution? So fossil evidence kind of provides a record of how the creatures had evolved through the information on the fossil. A lot of fossils do include the bones. It can have some skin particles. As I said, it could have a bunch of different things. It can have feces, all of that. That can kind of tell us a bunch of different things. It can tell us what they ate. It can tell us how their bone structure is similar to our bone structure, or possibly other animals' bone structure. Even plants, it can tell us how the plants had evolved and grown, and what they would be closely related to, and what is the closest thing that we can kind of date to it. And it also helps us identify it and link it to other additional things. Plants, animals, ecosystems, organisms, basically any organism like that. It can help us kind of differentiate everything. So that is the way that I believe it does kind of help support it, just based off of the evidence that I had kind of found throughout all of my research and all of the research that I had done. Its best way is to kind of help demonstrate the different things and kind of connect us to how everything evolved from the beginning, and it shows us just different signs of the evolution that we had experienced. Thank you.